Nos Franciscus Anelli, Rector Magnificus Universitatis Catholicae Sacri Cordis. Jon Rao, Nazione Indo et apud Indos in mathematicis, rationumque scientia erudito, qui docendi munus per decennia inter canadenses sustinuit, et laudes undique consecutus est, propterea quod eximiam doctrinam suam, ad inquirendas res economicas intendit, id potissimum studens, ut egestas populorum relevaretur, et uius orbis opes iuste atque integre dispertirentur. Titulum et privilegia doctoris scientiae economicae in agendo posite honoris causa decernimus.
Thank you. This is the memoir of our university, and this is your degree. Thank you very much.
Well, this is quite an honor to receive this prestigious Laurea Honoris Causa from the Catholic University of Sacred Heart. I thank the rector and Professor Maurizio Bausula for their initiative. This is my third visit to Piacenza. I'm enjoying it, and a wonderful hospitality, Italian hospitality, and the friendship I will cherish for a long time to come. So what I want to talk is just a introductory talk on the impact of sample surveys on social sciences. The sample surveys is the topic I work on, and I received a PhD in statistics, as Professor Bausula said, from Iowa State University, but I had a minor in economics, and the professor I worked with was a very distinguished econometrician named Professor Tintner. So I do have a connection to economics, and a lot of my work has some impact on social sciences and economics. What I want to do is I want to sort of trace the developments in survey sampling over the years and show the impact on social sciences in a lighthearted way. I had prepared some slides, but it's not possible to show the slides. So, okay. The earliest reference to drawing a sample from a population goes back to the great Indian epic Mahabharata, which was at least 1,000 years before Christ. You should all read Mahabharata. It's a great epic. And according to a story there is a king named Rituparna. He sampled few branches of a tree, few branches, and declared the tree has 2,095 fruit. So his assistant named Nala got intrigued. I said, how did you know just drawing one or two branches? So Rataparna replied, I of dice possess the science, and in numbers thus I am skilled. So in fact, so the origin of probability basically goes back to Mahabharata. The eminent French mathematician Laplace, you probably heard of Laplace, great French mathematician. He estimated the total population of France around 1780s by sampling about 700 communes scattered over the country, and he took advantage of the census of number of registered births. So the sampling origin goes back to even 1700, but the real progress came in around 1900. So there is a Norwegian statistician named Kier. He was the first person to promote sampling over complete enumeration. You see, until then people would not believe you can draw a sample and make inference. You got to enumerate everybody, called census. So the origin of sampling arrived around 1900. So he advocated what is called the representative method. What is a representative method? A sample should reflect the population through either balanced purposive sampling, that means you don't have to select a random sample. If you can select somehow balanced sampling to reflect the population, then it's a good sample, or random sampling. So this is what the Kier suggested that. And then in 1924, the International Statistical Institute had a committee consisting of the British statistician Bowley and the great Italian statistician Corrado Gini. And two others were asked to report on the progress of the representative method. So the Bowley, he came up with a very important contribution. He introduced the concept of a stratified random sampling. That means you group the population into partition the population into homogeneous groups, and then draw samples independently from each stratum through random sampling. And then in 1929, this is a very interesting thing because it's got Italian connection. Soon after the ISI meetings were held in Rome in 1925, the Italian Statistical Office wanted to keep a representative sample of the 1921 census in order to make room for a new census data. So they didn't want to throw it away, they wanted to keep it. So they assigned it to Gini. Can you tell us how to select a portion of the census and keep it? So Gini and Galvani selected a sample of 29 administrative units such that the sample is balanced on several important variables. So they selected some key variables and chose the samples in such a way the means agree with the population means. Now, I don't know exactly what they did because the paper was in Italian. So maybe some of you could read and let me know what exactly they did. Every time the people say, this is what they did, balance sampling, but I really don't know the procedure that was used. So this is a famous paper by Gini and Galvani, and you know Gini is a world famous for income inequality, Gini coefficient. I always admired Gini. You know, he said he believed in majority of methodology works arises from the need to solve concrete practical problems and considered statistics, economics, sociology, demography, and biology as closely related topics. You know, you should not look at them as separate. These days, they interact with each other, and it's getting more and more now. Then in 1934, a Polish statistician named Jerzy Neyman, he wrote a fundamental paper in 1934. And basically what he did, he showed that the Gini-Galvani method was not good. It gave poor results on certain variables where there was no balance. And then he proposed probability sampling, or what we call, you can select the sample in a very efficient way to reduce the cost and get very efficient estimates. And that led to what is called stratified random sample is preferable to balanced sampling. And he also introduced the concept of efficiency. You know, when you draw a sample, it should be efficient in the sense of minimizing a cost. So he produced a whole theory of efficiency and how to allocate the sample to the different strata, optimal allocation. And then he introduced the concept of a confidence interval. So, you hear the statements like, the margin of error is no more than 4%, 19 times or 20. You hear the statements when you have elections. They say, if this guy is going to win, the margin of error is no more than 4. So what Neyman did, he showed that through probability sampling, I can produce not only the estimates, but I can produce confidence intervals with a prescribed confidence. And this is done without any assumptions. So that was the big breakthrough. And so after that, it took off. The whole survey sampling went in the direction of Neyman. And what is interesting about Neyman is, Neyman is famous for hypothesis testing. Some of you students heard of Neyman-Pearson theory, hypothesis testing. He is the same guy. He went to US. He created a department of statistics at the University of California, Berkeley, very famous department. And that is the only paper he wrote on survey sampling. It's very strange. But he was the pioneer in survey sampling. And so after 34, there was a lot of momentum on probability sampling. And in India, there is a great Indian statistician named Mahalanobis. This is about 1937, 1940. India, you remember, was under the British till 1947. 200 years were under the British. There was very little infrastructure. Everything was imported from Britain. I remember when I was a little kid, I just faintly remember the British guys, officers all were British and things like that. So in 47, India got independence, and there was a huge crisis, the partition of India into Pakistan and India. 4 or 5 million people died during the racial riots. And that is the time Mahalanobis, made a fundamental contribution to Indian economy. And he created the National Sample Survey of India, which conducts continuing surveys on many subjects and employs a permanent staff and uses personal interviews for socioeconomic surveys and physical measurements for crop surveys. So and then he created the world famous Indian Statistical Institute in Calcutta. So that is the time, around 50s, I just finished my bachelor's degree, and I was looking for opportunity what to do, because India didn't have too many opportunities. But statistics, India was great. India had very famous statisticians. Somebody was asking me this morning, are you the guy who invented Rao inequality? I said, no. He's a great Indian statistician, also same name Rao, okay? But he was a student of Mahalanobis in Indian Statistical Institute. And there is also another great Indian statistician, survey statistician. His name is Sukhatme. He was an expert in agricultural surveys, whereas Mahalanobis was much more. But they didn't get along with each other. They didn't agree this is the way to do. And Sukhatme left India and went to Rome as the director of statistics in FAO. So there is a connection to Italian connection. Sukhatme was there, and he stayed there till he retired. And he went back to India and set up a institute in a place called Pune near Bombay, and did a lot of work till his death. That's Sukhatme. And around the same time, the Americans, US Census Bureau, under the leadership of Morris Hansen, created the whole theory of survey sampling. And they created the current population survey, which is like the Italian labor force survey. It's a monthly survey to estimate unemployment rates and other things. And they use what is called a stratified two-stage sampling, where you partition the population into primary units like municipalities or regions, and you select the units with the probability proportional to size of the unit. And he developed the whole theory during that. And US Census Bureau became a leader in survey methodology. And the basic idea was you do efficient survey sampling in such a way you can estimate the totals, means, and proportions for large samples. So that was the focus. Those days there was nothing available, so you started with the good intention of the large populations, and the designs were made for that. And also they were able to design it in such a way, you not only get the estimates, you also get the precision, how good they are, like confidence intervals and standard errors. These are the ones provided there. And during that time, I was a PhD student in Iowa, 1960s, and there was a challenge how to select more than one primary unit in a stratum with a probability proportional to size. And because Hansen only did 1 unit per stratum, he didn't know how to do the more than 1 unit. And I wrote a thesis and developed 2 methods which are used all over the world. Statistics Canada, they use it for the Canadian Labor Force Survey, they use it in India. So I have a fond memory of the probability proportional to size sampling. And as the time progressed, the interest was more on analysis of survey data. So social scientists take the survey data, they do all kinds of analysis, like a regression analysis. They prepare tables and test independence between the variables. All this is done during that time. And during that time, my professor, his name is H.O. Hartley, he developed a very ingenious method of estimating totals and proportions for groups not defined in advance. And what is interesting, he published this paper in a special 1959 volume in honor of Corrado Gini, so in an Italian journal. So for a long time, it didn't catch attention because, the Americans are too narrow in their perspective. Now, of course, with all the internet and all that, you can do all kinds of search. But those days, it wasn't there. Now, the social scientists, as I said, do a lot of analysis of data, regression, categorical data, logistic regression. But the problem is the survey data do not satisfy the assumptions. Because the design is geared to, you cannot draw a random sample of households from Italy. You have to do it in stages. Strata, first stage unit, second stage unit. So this is like the Italian labor force survey. So the data does not obey the standard assumptions. So in the 80s, I was involved in how to develop new techniques which would enable the social scientists to do a proper analysis of the data. And this leads to what is called a design effect. You have to account for the design effect. And there is a great social statistician named Leslie Kish. He drew attention to this problem and emphasized the need for suitable corrections to the standard. You run a program, an SPSS or a SAS or something, it could be wrong, totally wrong. So how to adjust that is a thing going on. Now when the computers have come, now there's, you can do almost anything on the computers now. So we are now developing more intensive techniques. For example, there is something called resampling techniques. You sample from a sample many times. Okay? So each sample you create new values of what you call the design weights. So you will get, say, 500 samples you draw. You create 500 weights, and you have the response variable and the original weights. You give the data file to the sociologist. All he has to do, social scientist, he takes each column and runs through SPSS or SAS. You'll get 500 estimates, and you just take the average of the estimates and sum of squares, between sum of squares. And in fact, the social scientists are so happy with this recipe because they told me once, we are so happy because we don't have to see you anymore. We can do it our own. You just give us the weights, we know the programs, we can do what you want. So, well, that's not a good attitude, but, if we can help them do their analysis properly, that is a great satisfaction for a survey samplers. The latest topic I was working on is a small area estimation. This is where Professor Bausula had a conference, 2005, is it? Yeah. And it was one-day conference. It was all in Italian, except my talk. but I was able to follow the Italian reasonably well, in the context, like today, I was able to follow a little bit. And here there's a lot of challenge because you are now asking too much. You are asking, produce estimates for small areas, local areas, like a municipality, a county, a small industrial division. But the sample is drawn, I cannot draw a million sample size. I only got 50,000. Because of the cost consideration, you cannot do that. And yet you want estimates for those local areas. And in fact, you may not have any sample size. So it's a real challenge. So you need to develop models and link the areas together. So it is not only theoretically challenging, but it's very practically important. And Professor Bausula realized this importance, and he makes a quote here. Increase of the sample size is seldom a viable option to support reliable area-specific estimates for all domains of interest. So currently there is a tremendous interest in poverty statistics at the municipality level. In Europe there is a lot of interest. Last year I was traveling all over the world. I was in South Africa to give a 2-week workshop on small area estimation. I was in Mexico City. Everywhere I go, they said, please tell us how to estimate poverty rates, poverty gap, poverty severity, all kinds of statistics from a very small sample or no sample at all. So it's like a magic. It's not that simple because you need lots of data. Census data, administrative data, the models. You got to interface all of them together and do research. You have some very good people in Italy working on this topic. Their group in Pisa here, we have Enrico Fabrizzi works on this. So it's a very exciting topic. I wrote a book in 2003 on this topic, which seems to have drawn a lot of attention. And now I'm told to revise the book, second edition, which is a nightmare because what has been done in the last 10 years is just too much. I got to summarize all that. It's not going to be that easy. I want to end my talk with some current and future research developments. Now what is happening is the data collection now has completely changed. It's no longer personal interviews, you go on there. Now it's cell phones, internet. So the methodology we have developed earlier is not necessarily valid for this. But at the same time, we cannot say, go to hell. We have to provide this. I was in Brussels last week. There was a big conference on new technologies and techniques in statistics. And the whole conference was focused on what is called big data. What is big data? The data collected on the internet, like Twitter, Google, Facebook. And the amount of data available on the internet through the big data is getting so big. One of the keynote speakers, the former director of the Bureau of Census at the US Bureau, he said that if the social scientists and the statisticians, survey statisticians, don't start blending the traditional methods with the big data, we are out of business. So this challenge, so there are a lot of people who were asking me, how do I do small area estimation using all this big data? Now, I don't know anything about big data. I don't go to Twitter. I don't go to Facebook. So I got to learn what the heck is this data all about. It's getting bigger and bigger, millions and millions. But there is a useful information there. So we need to put them together. Now, there is some interesting research done in Italy on how to sample hard-to-reach populations. You got a lot of illegal immigrants. You want to learn their characteristics. I had a visitor, Fulvia Macati from the University of Milan. What is it? Yeah, okay. She visited me twice, and she wrote a very nice paper on how to do this difficult problem using incomplete frames. Like, you got a list of people who go to mosques, you got a list of people who go to railway stations, a list of people who get together somewhere. You blend them all together and produce estimates. This is a very interesting area. Then there is a lot of interest on missing data. people are not responding anymore. The response rates are coming lower and lower because there are so many surveys. I don't know about Italy. In the US, for every little thing, they do a survey. There are so many survey organizations in Washington, for example, unbelievable number. Everybody is doing surveys. So people getting fed up. In Canada recently, they canceled the long form census. See, we have two censuses. One is the short form. I don't know, the Italians have a short form census. The basic data collected on every individual once in 10 years. We have once in 5 years. And there is a long form where more extensive data is collected every 5 years on a 1 in 3 or 1 in 5. So our Prime Minister decided it was compulsory. You have to answer. Otherwise, there is some punishment. So our Prime Minister decided to scrap it and make it voluntary. And his argument was, people don't want to, tell how many bathrooms I have. It's none of your business. Privacy consideration. So it played a havoc in Canada. People started screaming, you're destroying everything we have built. Statistics Canada is the #1 agency in the world. So the chief statistician had to resign. They brought in a new guy. So now they got a voluntary census. And now the challenge is there's a lot of non-response. So this is one thing going on now. So things are changing. Missing data is causing a lot of problems. And one of the ideas is how to fill in the missing values, one thing. And then once you fill in, how do I analyze the data? Because missing values are not true values. So if you treat the missing values as true values, then you get very misleading answers. So this is another challenging problem. There is another topic which is very popular these days called statistical matching. You got many data files. You're interested in relationships, but you don't get any data file with all the variables. You get some variables here, some variables there, some variables somewhere else. How do I integrate them so that I can make an analysis of the data? So this is a very challenging problem. So survey sampling is going through a tremendous change and very exciting. And I'm looking forward to a lot more, at least during my lifetime. I'll see some more things. So I want to conclude. I traced some developments in sample survey theory and methodology that had significant impact on social sciences. New developments are taking place to address challenging problems in social sciences and other areas, as I outlined. And the Italian statisticians and sociologists are contributing tremendously, and they have a world recognition, and it will continue to do so. And I'm delighted to come to receive this honorary degree. It's a great honor, and I will cherish it very much. Thank you.
Bene, ringrazio nuovamente il professor Rao per la sua Lectio. Non vi è luogo di aprire l'anno accademico già aperto. Ringrazio tuttavia tutti coloro che sono intervenuti e dichiaro chiusa la cerimonia. Grazie.